Hey, what's up, arcade nerds? No, I'm just kidding. That's Arcade Jason. But I was posting, there were some questions about this GQ-4X, and then I got motivated and intrigued, and I wanted to do some testing, so I took it apart. And one of the things is it was kind of insinuated that you could adjust the voltages, and you can. There's a couple DC to DC voltage. Dang, that's bad shadow there, but let's see if I can actually get that lit up somewhat. Without a shadow is kind of hard, huh? There we go, somewhat. Anyway, there's two of them, and I believe these two right here, one's for the Vpp programming voltage and one's for the Vcc. That's my theory, and it's kind of fixed. There's only so many variances I think you can do based off of the resistor values, and I think it's these resistors here that's controlling the DC to DC conversion. So like 5 volt from the USB is coming in, and then it's getting bumped up to 25 volts Vpp, or like 5.5 Vcc, or it's going down based off of the resistors here, etc. So anyhow, on this side, there's actually a little header that I was interested in, and it says, let's see if I can get this. There we go. Vpp, VDD, ground, PGD, and PGC. Now, I don't know what those mean. Except for Vpp is obvious. So then I figured I would hook it up to my multimeter while it ran some tests and figure it out. So I'm pretty sure Vpp, we know what that is, and the VDD one is for the right VCC in the settings. So what I figured we'd do is just run a test real quick and see what the output voltage is, and then how you can control it. I came over to my computer, and I have the GQ-4X plugged in. I have my red lead on the Vpp header there, and ground connected to ground, and then I have my multimeter right there. So, whoops. Let's see if. I'll be right back. Let me set it up. So here we go. There you can see the voltmeter, the VCC, and then hopefully you can see this. So when I come to the help file, you can see it says the different VCC supported and the Vpp supported. So I wrote those down in our handy dandy notebook right there. 3.6 volts, 5 volts, 5.5, 6.2, and then your Vpp, you actually have 1, 2, 3, 4, 5, 6 different settings. And what you do is you come to the devices file, and you can actually configure these. Sorry, I know this would be easier if I did a screen grab or something like that, but basically you can come in and configure your own EEPROM settings. You have to, give it a name, and it can be something arbitrary, obviously. Then you have the class. Now this class is required. I don't know everything it's setting, but probably like the dip package and stuff, I don't know. So I just picked 2716, and then category, speed is optional, obviously, and all of these are really optional. It will take this class, where am I at? It will take this class and set these values, but we can also override them. So what we're going to do is we're going to go through and test these and change these settings in the system. So this is our 25 Vpp test, and then we will come to our programmer and select under device. We're going to choose jacklick. And it's right there. Okay, and then we come to this screen, we'll hit our info button, and we get, okay, the class is this, our speed is 1, I'm curious about that, sorry for the shaking here, VCC is 5 volts, VPP is 25, and write VCC is 6.2. So we manually changed that from what the defaults are. And let's see if, oh, you know what? The speed actually worked. It set it to speed. What did I have it in? I had speed 1. And it obviously set it to speed 1 right there. Did it? Or speed 5? No. See? I don't know what the heck it did. So it set it to speed 5, which is the slowest, and I had the settings set to speed 1, I think, right? Yeah, whatever. So that, I don't know what's going on with that setting, but whatever. That doesn't matter. So okay, so now what we're going to do is we're actually going to hit. Let's see if can I fill the buffer. I'll just hit right. The buffer should be empty. Okay, it's all F's. So I can hit right without a chip in here, and we'll watch what the voltmeter does. And I'm expecting it to be around 6.2, right? So let's hit right. It's writing it. Okay, that's not what I'm. That doesn't look right, does it? Our verify voltage is at 4. Oh, you know why? I'm on the VPP over here. Duh. Let me pause and reset that on the right set on the right header pin there, so to get an accurate measurement. So we're going to hit right again. There, hitting right. 6.45 volts. 6.45 volts. And I think I hit right twice. As a real quick test on the speed thing, I'm going to change it to speed 3 and see what happens there. So we're going to just save this. Let me see. Click that, and then we actually have to close the programmer. And we got to crash. All right. Relaunch the program. There we go. And let's see. What do we want to do here? Okay, yeah, we're going to choose our device and go over to Jacklick. I put it in my favorites. Look at that. The setting does work, but it seems like it's opposite. Like if I click on this, +2, it says that's speed 1. But really that should be, in the devices file, speed 1 translates to speed 5, right? Which is the slowest. It's like, I think we found the bug. It's basically like inverted. So every time, maybe the class of chip says speed 1, you know what I mean? And that's why it's always set to the highest speed, which really should be speed 5. Anyway, there's a freaking bug there that we just figured out. So, all right, I'm going to set it manually to the lowest speed, which is, it says it's speed 5, but the setting in the device's text file is speed 1. Go figure. All right, so what did we do? We changed that devices file, and now we want to, let's play with the numbers. Okay, so what we're going to do is we're actually going to try, let's keep testing the VCC voltage. And so we're going to change this to be, let's change it to 6 volts. Just straight up 6 volts. We'll hit save. We'll restart our program. So we gotta close it down, relaunch it, and it says 6 volt is not available. So it knows, the program knows that it has to be one. Oh, we got another crash, which is nice. The program knows that it can't parse 6 volts for write VCC, so it has to be, the next one would be 5.5. We'll hit save. Let me change this a little bit. I've been running this in compatibility mode, but alright, and let's choose our device. Alright, so we have our speed set to 0 now. Totally does not make sense. Like, I mean, I wish they would change this here. Alright, so now we manually changed our speed to 5, and we're going to hit write, and then look at our test here. We have it set to 5.5, but it's actually putting out 5.6. So that's plus or minus, usually 10%. And then when it goes through the verify function, it should be around 5 volts, but we're like at 5.2. So, all right, let's go back and modify our file, and we'll test 3.6 volt. 3.6. We have to save it. The devices file. Close down the program. Relaunch it. And choose our device again. Alright, change our speed, hit write. Let's see what we get. 3.1. It's not even close to 3.6, is it? So kind of there's definitely a range here that's could be unacceptable for some chips, and you can see why, I guess. All right, let's go to, maybe, you know what, let me plug in my external power and see if we get more consistency. My external power plugged in. I'm going to hit write again. Yeah, we're still at like 3.2 volts. That's the verify function right there. It's at 5.2 for some reason. And on our settings here, read Vpp, blank VCC, write VCC. It's right there, 3.6. Let's go to 5. Hit save. Relaunch our program. Alright. Well, I'm at 5.6. Doesn't make sense, does it? Is my measurement different? That location is not what I think it is, maybe? I don't know. I mean, the best place to measure would be obviously on the pin itself, because I don't know what VDD VDD actually means for this thing. Let's experiment with the VPP function. Okay, I changed our where's it at? VPP, or no, I'm sorry, the let's see, VPP. Where's my VPP? Yeah, write VPP. Let me see. Let me come back. I can't remember if I was changing the right VPP or the right VCC that we were measuring, so I have to go back. Maybe all those tests were. But anyway, we're going to check the programming voltage, which is the WVPP, and we're going to set it to 3.6. I changed my jumper location to be on VPP. I also changed my speed to be 1 right there, and we'll hit save, and we will close. Oh, the other thing I was going to show is if you want there's a setting under settings. If you go to other, you can choose to load the last device when you start up. So I had that unchecked, but we can check that, and also ignore loaded file path, because usually when you're programming stuff and then you delete a file, it'll always give you an error. So anyway, there's that setting there. So we're going to close that, reopen it. Now there's another bug right there, because I didn't see it saying that I have a path that's not found. And in my settings, I don't even have that selected. I have, oh wait, no, I need to select that. Ignore loaded file path, that's what I want. Duh, okay. Maybe that's what it is, I don't know. Alright, so our speed is correctly set. And we're going to actually hit our right button. No, not, yeah, what's going on? Okay, I figured it out. See if I can zoom in here. I had to actually fill the buffer. It was empty with all Fs, hex F, so I just filled it with all 1s. If you go to File, edit, fill buffer hex, and then I just filled it, like I could fill it with, all, 1s or A's or something else. I just hit that, and then now, let me choose device, jacklick. All right, and right now we just have it default, so 25 volts is our VPP. I have my meter on VPP, and we are going to let's turn that on like that. We're going to hit right. No, it says right failed. Why did it do that? That's crazy. Let me close that down. Alright, but I'll come back and we'll do it. I don't know why it won't complete, but I was able, I'm changing the VPP to 21 volts. And then if I come to my buffer, I have it filled with all 1s, and then I hit right, it says 21.3 volts. So we're actually able to measure it, but it fails at 9%, maybe because there's not a chip in there. I don't know. I could have swore I got it to do something before, but whatever. We can test. Let's go to 12.7. Let's go to 15 volts. Actually, let's go to 15. Like right there. Hit save, and we have to close our program. I have it running as administrator. This thing. Alright, choose our device. We got to do all these steps here. Fill our buffer. And then we can even uncheck verify and double right if we wanted to. Hit right, and we get 15.75 volts. So that looks like it's working correctly. Anyway, so but it fails at 9% for whatever reason. Not sure why. But anyway, I don't know if I have any results or conclusions except for, you know, it seems some of the voltages seem a little bit off, but not too much, and that you are restricted to just the 6 different VPP programming voltages. So that's really okay. One last test here, because I don't think when I first was doing this, I wasn't doing my test right. I had to actually fill the buffer with some data for it to get correct readings. So I changed my VPP to 12 volts and my VCC, or my right VCC, to 3.6, and I moved my connector there over to what is labeled as VDD on that header pin there. So let's go ahead. I already closed and opened up and filled the buffer with ones, and let's see here, let's hit right, and then we get 3.45 volts, so pretty close to the 3.6. Again, it locks up at 9%. It doesn't finish, probably because I don't have a chip in there, but not that it would actually program at that anyway. But and let's do it again, but move this over to the VPP. We'll hit right, and we get 12.8 volts, and I have it set for what, 12? Yeah, I have it set for 12, and it's at 12.8, so not right on the numbers, obviously, so there's plus or minus a range there. Anyway, hopefully this is somewhat interesting. It was interesting to me to figure it out. So all right, let's see. After it stops beeping, just for completeness, there is this hardware test where you can actually do a voltage diagnostic on the unit, and I figured what I'd do is I'd run the test. All you do is hit test, and then I'll film what the voltage is real quick. So let's see here. All right, I'm hooked up to the VPP, so I'll run the test real quick. And it helps if I put it on volts, obviously. We'll run that test one more time, okay? So because it goes fast, that's why I could have done this in the beginning, but it goes so fast that I wanted to be able to do it on a per configuration basis. But we'll run that test again. And there's nothing happening now. And then when you see it there's 12, I guess, so, I don't know, it happened so damn fast. So I'll pause, or actually let me keep running it. No, I'll pause and change it to the, change where my red lead is to the VDD location, which should measure the right VCC. Right, let's hit test again, and we'll see the right VCC. There we go. 3.5, 5, something, 6.5. So anyway, it happened so fast, so I just wanted to show that real quick. Now the video's done.